Hello students. In today's class we will discuss the Rankine cycle and its different processes. The Rankine cycle is the modified version of the Carnot cycle as it overcomes the demerits of Carnot cycle, so it is more practical cycle. All the power plants runs on the Rankine cycle. In the Rankine cycle, the heat energy of the fuel is get converted into mechanical energy or power. The Rankine cycle has mainly four processes takes place in that four different components. These components are first is boiler, second one is turbine, next is the condenser, and the fourth one is the pump. By one we will discuss the different process and the function of this component. First of all, we will discuss the function of the boiler. In the boiler, constant pressure heat addition process takes place. Let's say the water at conditions or state 1 enters into the boiler and gets converted into saturated steam and goes out of the boiler at state 2. The fuel is burned inside the boiler in the combustion chamber and produces heat. The chemical energy of the fuel converted into the heat energy, and that heat is absorbed by the water. And the heat from the fuel is absorbed by the water, and water which enters at state 1 is get converted into state 2, that is steam, at a constant pressure. We can see the process 1 to 2, that is boiling process, in the PV diagram at a constant pressure, that is shown in the PV diagram from process state 1 to state 2, the process 1 to 2. In the boiler, as heat is added into the water, it changes its phase from liquid state to vapor state. This line shows the saturated liquid line, and this side line shows the saturated vapor line. The left side of the saturated liquid line is the purely liquid state, and the right side of the saturated vapor line shows the pure vapor state or superheated vapor. And from the saturated liquid to saturated vapor line, it is liquid plus vapor state. So when the water enters into the boiler at state 1, it may be saturated liquid or simple liquid. So first, by the addition of heat, the liquid changes to saturated liquid by sensible heating. Then from saturated liquid to saturated vapor, it changes its phase by addition of latent heat. Then the outlet of the boiler may be saturated liquid, wet vapor, or saturated vapor, wet vapor, or superheated vapor. The point 2 dash shows the saturated vapor, and point 2 shows the superheated vapor. The superheating of the vapor from 2 dash to 2 takes place in the superheater. The heat addition to the water or steam can be calculated by the change in enthalpy, that is H2 minus H1. The second point or 2 point is will be the enthalpy will be more. So we will find out the heat addition in the boiler at constant pressure, that is Q1 to 2 is equals to H2 minus H1. The superheated steam at state 2 then enters into the turbine, and in the turbine it is expanded in isentropically. That means reversible adiabatic process takes place in the turbine. The steam is expanded from state 2 to state 3. We can see the process 2 to 3, that is isentropic expansion process in the turbine in the line diagram. That is the steam coming out of the boiler at state 2 enters into the turbine, and the high pressure and high kinetic energy steam is when enter into the turbine, it runs the turbine, rotates the turbine blade by giving its energy into the turbine blades and losing its energy, and by the process the steam is expanded, loses its energy to the turbine blades, and the turbine blades by gives rotational energy or mechanical work, which is then get out of the which is the mechanical output work output by the turbine is then gets converted into electrical energy by the help of the generator, as the turbine shaft is coupled with the generator shaft, and which is then converted into electrical energy. The steam which enters the turbine at state 2 comes out at state 3, has given its energy to the turbine blade and loses its energy, and its enthalpy drops from H2 to H3. So the work done by the turbine in the process 2 to 3 can be calculated as Wt is equals to H2 minus H3. We can see the expansion process in the PV diagram by the line 2 to 3, which is the isentropic expansion process. Enthalpy drops from H2 to H3. Pressure of the steam also drops from the boiler pressure P2 or P2 equals to P1 to the condenser pressure, that is P3. The expanded steam at state 3 then enters into the condenser, in which the condensation process takes place. As we know, the condensation is the process in which again the steam will convert or change its phase into the liquid state by giving its heat. So cooling water supply is given to the condenser, which takes away the heat from the steam which is coming out of the turbine, and that steam is get converted into water by losing its latent heat, and the cooling water gets that heat and comes out of the condenser. Again we can see the line diagram in which the condenser is shown. The steam is coming out of the turbine at state 3 and entering into the condenser either superheated vapor or saturated vapor, or it may be wet vapor. Then in the condenser it gets condensed, and saturated liquid will leave the condenser at state 4. We can see the PV diagram of condensation process, that is 3 to 4. In the 3 to 4 process, constant pressure, the pressure remains constant, and the 3 point is in the saturated vapor region, that is liquid plus vapor, but it may be depending upon the conditions, the 3 point may be in the wet region, that is liquid plus vapor, or in the saturated vapor line, or it may be in the superheated vapor region. From whichever state the steam is coming out of the turbine, it enters the condenser, and from that state the condensation process will start, that is 3 to 4, and the outlet of the condenser is always saturated liquid state. Now come to the line diagram again. The state 4, which is the outlet of the condenser, at that condition the liquid water is saturated liquid water will enter to the pump at condition or state 4. Then the pump will supply the water to the boiler from the condenser, and as the boiler is at a higher pressure, and so the pump will increase the pressure by compression process, that is isentropic compression. So it will increase the pressure from the condenser pressure P4 to the boiler pressure P1. So in the pump, the compression work will be done to increase the pressure. Some energy will be given to the pump, and that is negative work done as we are giving energy or work done into the pump. So the work done by the pump will be H1 minus H4. H1 minus H4 will be the isentropic work done in the pump. Now let's see the TS diagram of the Rankine cycle. As we know the four processes of the Rankine cycle, that is 1 to 2 the constant pressure boiling process, 2 to 3 is the isentropic expansion in the turbine, then 3 to 4 is the constant pressure condensation process in the condenser, and 4 to 1 is the pumping process or isentropic compression process in the pump. So let's see the 1 to 2 boiling process. The 1 to 2 curve shows the constant pressure boiling in the boiler, in which first from 1 to 1 dash, sensible heating of water, liquid water, that is in the liquid phase takes place. Then when the saturation temperature reaches, that is from 1 to 1 dash, the sensible heat addition will takes place in the water in the boiler, and when the point saturation temperature for the boiler pressure reaches, that is point 1 dash, the boiling of the water starts. That is from 1 dash to 2 dash, the boiling or the phase change of the water takes place by addition of latent heat into the water. Next, when the saturated vapor then get more heat or more sensible heat, then it get converted into superheated state in the superheater. So 2 dash to 2 process shows the superheating process. 1 to 1 dash is the heat addition or sensible heat addition in the liquid water. 1 dash to 2 dash is the phase change, that is at constant temperature and pressure the liquid water changes in phase to the vapor, saturated vapor condition. Then from 2 dash to 2, it is again heat is added to the saturated vapor and it goes to the superheated region. Superheated state comes at state 2. Then at the state 2, the superheated steam gets out of the boiler and it goes to the turbine. As we consider or negligible all losses at the same condition, at the same state at which the steam get out of the boiler enters into the turbine. So the turbine process or the expansion process shows by the vertical line, as it is an isentropic process, constant entropy process. So it shows in the TS diagram by an vertical line, that is 2 to 3 process is the process takes place in the turbine, in which the steam is expanded and we get the work done by the turbine WT. As it is an isentropic process, that means constant entropy process, so S2 is equals to S3 and the constant entropy line in the TS diagram is a vertical line. Next, from the turbine, the steam, expanded steam or the low pressure steam enters into the condenser. The 3 to 4 process shows the condensation process in the TS diagram. It is an horizontal line. Now we will find out the efficiency for the Rankine cycle. As we can see, there is 2 heat interaction processes and 2 work interaction processes. Heat is given to the steam or water in the boiler, that is Q1 to 2. and heat is coming out of the system or from the steam in the condenser, that is Q3 to 4. And similarly, work is coming out of the system, that is WT in the turbine expansion process, and work is given to the system, the water in the pump by the compression process, that is WP. So when we will calculate the efficiency, that is efficiency equals to output divided by input is equals to, output will be the W net work output, that is WT net work output divided by input will be our heat given in the boiler Q1 to 2, and W net will be the positive work minus the negative work, that is positive work is the work output from the system, and negative work is the work given to the system in the pump, that is WT minus WP divided by the input will be our input energy will be our heat in the boiler Q1 to 2. So the WT will be the enthalpy change in process 2 to 3, that is 2H2 minus H3. Similarly, the enthalpy change in the pumping process will be H1 minus H4, as H1 will be more after compression, enthalpy will be more, so H1 minus H4. Similarly, the heating process is from 1 to 2, so the the heat given in the boiler will be H2 minus H1. Okay, so equals to this is the efficiency formula for Rankine cycle. And if we will, in some cases, so the pump work is very negligible as compared to the turbine work, so we can neglect it. By neglecting the pump work, the efficiency will be H2 minus H3 divided by H2 minus H1. This will be the formula for the efficiency. Students, here we see the Rankine cycle, its PV diagram and TS diagram, and the calculation of its efficiency. Thank you, class. Thank you.